Hi, I'm Professor Barber. This lesson is titled The Unit Circle. The learning objectives for this lesson are 1. Demonstrate understanding of the unit circle. 2. Be able to determine points on the unit circle. And 3. Be able to compute the reference number. 1. The unit circle. In this lesson, we will explore some properties of the unit circle. The unit circle is the circle of radius 1 centered at the origin on the xy plane. Its equation is x squared plus y squared equals 1. Exercise 1. Show that the point -5/7, -2 times the square root of 6 divided by 7 is on the unit circle. To demonstrate that a point is on the unit circle, we satisfy x squared plus y squared equals 1. So we will substitute -5/7 for the x and square that, and then substitute in -2 times the square root of 6 divided by 7 and square that. What we need to do is see if that actually equals 1. -5/7 squared is positive 25/49. -2 times the square root of 6 squared is -2 times -2, or 4 times the square root of 6 squared is just 6. So 4 times 6 is 24, and 7 squared is still 49. Does that equal 1? Yes, 25 plus 24 is 49, and 49/49 does indeed equal 1. Exercise 2. Find x so that the point x, negative of 7/25 is on the unit circle in quadrant 4. The unit circle means that the statement x squared plus y squared equals 1 is satisfied. We are solving for x in the equation, so we have x squared plus the quantity -7/25 squared equals 1. Proceeding, x squared plus -7 times -7 is positive 49, and 25 squared is 625. That equals 1. Solving for x squared, you have x squared is equal to 1 minus 49 divided by 625. As a courtesy reminder, when performing a fractional subtraction, you must have a common denominator. So change the 1 to 625 over 625 minus 49 over 625. This difference gives you 576 divided by 625. So now we have that x squared is equal to 576 divided by 625. In order to solve for this, the root property tells you you're going to have plus or minus. The square root of 576 is 24, divided by the square root of 625 is just 25. We have to decide, is it the positive or the negative value? So let's look at the problem where it says it needs to be in quadrant 4. Here's 1, 2, 3. And in quadrant 4, we see that the x component is positive and the y component is negative. So in solving for the x, we want the positive value. The x value for which this point would be in the unit circle in quadrant 4 is x equals positive 24 divided by 25. 2. Terminal points on the unit circle. Suppose t is a real number. Mark the distance t along the unit circle, starting at the point 1, 0, and moving in a counterclockwise direction if t is positive, or in a clockwise direction if t is negative. In this way, we arrive at the point x, y called the terminal point, determined by the real number t. Continuing with terminal points on the unit circle, the circumference or the distance one time around the unit circle is the distance 2 pi. An approximate value for pi is 3.14. To move a point halfway around the unit circle, it travels a distance of pi. And to move a quarter of the distance around the unit circle, that travels a distance of pi divided by 2. Exercise 3. Find the terminal point on the unit circle determined by each real number t. A. T equals 5 pi. To determine the terminal point, begin at 1, 0, and 1 revolution gets us back to the same point, so subtract 2 pi, ends up with 3 pi. We have another revolution, so go around one more time, still ends up at the same point, subtract 2 pi, and now there's pi remaining, so we travel again. Another pi, we get that the terminal point, it's all scratched out now, is the ordered pair, -1, 0. Now, part B, t equals minus 3 pi over 2. Again, we begin at 1, 0. However, the negative tells us that we go in the clockwise direction. So in the clockwise direction, we travel along the unit circle 3 pi over 2 units. Terminal point then is 0, 1. Then part C, t equals pi over 2. Start at 1, 0. Travel along the distance pi over 2, which is a quarter of the circle, and that gets us to the terminal point 0, 1. 3. The reference number. Let t be a real number. The reference number t bar associated with t is the shortest distance along the unit circle between the terminal point determined by t and the x-axis. To find the reference number, denoted t with a bar above it, it is helpful to know the quadrant in which the terminal point determined by t lies. If the terminal point lies in quadrants 1 or 4 where x is positive, we find the reference number by moving along the circle to the positive x-axis. If it lies in quadrants 2 or 3 where x is negative, we find the reference number by moving along the circle to the negative x-axis. Exercise 4. Find the reference number for each value of t. A. T equals 7 pi over 6. It is helpful to know the quadrant in which 7 pi over 6 lies. So let's mark the t values we already know, which are along the axes. Starts at 0. Quarter of a way around the circle, the t value is pi over 2. Halfway around, or the semicircle, the t value is pi. Going another quarter of the distance, the t value is 3 pi over 2. And after you make the entire revolution, the t value is the circumference, which is 2 pi. Now, knowing our fractional values, we can see that t equals 7 pi over 6 lies in the third quadrant. So now following the directions, we'll find the distance between 7 pi over 6 minus the axis distance, which is pi. And that will be 7 pi over 6 pi would be 1 pi divided by 6. So the reference number that corresponds to t equals 7 pi over 6 is pi divided by 6. Let's continue. For t equals 3 pi over 4, again, we need to determine first the quadrant in which 3 pi over 4 lies. Starting at 0, quarter of the way around the circle, top of the y-axis here, we're going to have pi over 2. And then continuing around, the other side would be pi. At the bottom is 3 pi over 2. And finally, finishing out the circle is 2 pi. Now, knowing the fractions, 3 pi over 4 is somewhere between pi over 2 and pi. So we can say that 3 pi over 4 lies in the second quadrant. To get the reference number, we take the pi and subtract 3 pi over 4. Performing the fraction, getting a common denominator of 4, so we do 4 pi over 4 minus 3 pi over 4. That difference will give you the reference number of pi over 4. C. T equals negative 2 pi over 3. Now remember, we still need the distances, the standard ones, so 0, quarter of the distance in the positive direction, pi over 2, pi, 3 pi over 2, and finally 2 pi. The negative instructs us to go in the clockwise direction. So in the clockwise direction, we see that 2/3 is still somewhere between 1/2 and 1. That gets us into the third quadrant. And to find the shortest distance between this t value and the x-axis, we would do pi minus 2 pi over 3. That gives you the distance of pi over 3. So the reference number we denote with t bar is equal to pi over 3. That is this distance from pi going in the counterclockwise direction to negative 2 pi over 3 is pi over 3. D. T equals 5.50. The best that we can do here is use an approximation. So we'll use pi is approximately 3.14. Then 2 pi would be approximately 6.28. Letting t equal 5.50, traverse the counterclockwise direction to the fourth quadrant at t equals 5.50. We are looking for the difference or the distance between this t value and the x-axis. So use the approximate value of 6.28 for 2 pi minus 5.50, the given t value, and that would be 0.78. Common terminal points. We'll complete the table as we algebraically determine some of the missing values using the unit circle. We know for t equals 0, the terminal point is 1, 0, and we also know for t equals pi over 2, which is 1/4 of the circumference of the unit circle, the point is 0, 1. Let's now consider t equals pi over 4. The line y equals x intersects the unit circle at t equals pi over 4, which is also midway between t equals 0 and t equals pi over 2. Substituting x for y in the unit circle equation, we can get x squared plus x squared equals 1. Let's solve for x. Adding the two x squareds together, we get 2x squared equals 1. Divide by 2 on both sides, and we get x squared equals 1 over 2. Using the square root property to solve for x, we'll get x equals plus or minus, the square root of 1 is just 1, divided by the square root of 2. Since t equals pi over 4 is in the first quadrant, we will select the positive value. So x is going to be equal to 1 over the square root of 2. And since x equals y, the y value is also 1 over the square root of 2. Rationalizing the denominator, the terminal point determined by t equals pi over 4 is the ordered pair square root of 2 over 2, comma, square root of 2 over 2. So we'll write square root of 2 over 2, square root of 2 over 2 for the pi over 4, and mark it on the unit circle as well. Now pi over 6. Solved similarly as for t equals pi over 4 is the square root of 3 over 2, comma, 1/2. And pi over 3, solved similarly, is 1/2, comma, square root of 3 over 2. 4. Use reference numbers to find terminal points. To find the terminal point P determined by any value t, do the following. 1. Find the reference number denoted t bar. 2. Find the terminal point Q, ordered pair A, comma B, determined by the reference number. And 3. The terminal point determined by t is the ordered pair plus or minus A, comma, plus or minus B, where the signs are chosen according to the quadrant in which the terminal point lies. Exercise 5. Find the terminal point determined by each given real number t. A. T equals 7 pi over 6. In a previous exercise, we determined that 7 pi over 6 lies in the third quadrant, and we also determined that the reference number that corresponds to 7 pi over 6 is pi over 6. The terminal point that corresponds to pi over 6 is square root of 3 divided by 2, comma 1 divided by 2. Now making and accounting for the fact that 7 pi over 6 lies in the third quadrant, we can adjust the SIGNs so that the x value is negative, so it would be negative the square root of 3 divided by 2, comma, the y value is also negative, which would be negative 1/2. B. T equals 3 pi over 4. In a previous exercise, we determined that t equals 3 pi over 4 lies in the second quadrant, and the corresponding reference number denoted t bar is equal to pi over 4. We computed the terminal point for pi over 4 and found that to be the square root of 2 over 2, comma, square root of 2 over 2. Now, making and accounting for the fact that 3 pi over 4 lies in quadrant 2, that means the x value is negative, so we'd have negative the square root of 2 over 2, but the y value is positive, square root of 2 over 2. And C, t equals negative 2 pi over 3. Again, in the previous exercise, we determined that this number lies in the third quadrant, and the corresponding reference number is pi over 3. From the table, we know that the terminal value that corresponds to this is 1/2, square root of 3 over 2. Now, making an allowance for the fact that the value negative 2 pi over 3 lies in the third quadrant, the terminal point would then be negative 1/2, negative square root of 3 over 2.